Hey all, we're going to get started on this first video here. We're going to be doing the uh, Microcorruption CTF. We're going to start with New Orleans, which is the first example after the tutorial. As you can see, I've already done a couple, full disclosure. That was before I decided I was going to record it. I did the first two, and then I decided, oh hey, this would be a really good, interesting thing to do. So at that point, I stopped. I took some time off between just to kind of try to forget exactly. But just so you know, this won't be exactly the same as what I envisioned for this channel because I have had at least a little exposure to this one. So, but as you can see, I have not gotten very far. I have not done Hanoi or Reykjavik yet. So, yeah, let's try this out. We're going to jump right into New Orleans. I assume you've looked over the tutorial, which walks you through step by step, what every part of the screen is here. And so this is just kind of details about the lock. We're using version A01. It's controlled by an MSP430 microcontroller, which is a really interesting choice for them to use because that's actually like a pretty simple like hobbyist level microcontroller. So lots of good information out there about it. So this is good. One thing I'm not going to do, which it's just my style. There's a lock manual here, as well as we could go, of course, get the entire MSP430 documentation and read it cover to cover before we ever start. And that's really probably a great way to go about it if your brain can process information that way. I cannot. I need to see something in the real world, kind of look at it, think about it, and then when I read the documentation, it will start to make more sense. So, but for right now, we are just going to dive in, right, knowing very, very little about anything. I'm assuming you've done the tutorial, so you understand, here's the disassembly of the code, here's the dump of what's in memory, our console, input, output, and we're going to toggle this screen to minimal mode. So here we go. Here we have our registers. We have the currently executing command. So we are now connected to this lock. So we're going to go ahead and type help, just first and foremost, just to refresh our memory as to what our options are in here. We can solve the lock, reset the whole system, continue, step over, break, unbreak, read, track, or let, or breakpoints, show a list of breakpoints. Okay, cool. So the first thing we're going to do is we're just going to start the program, let it run. We got to see what it does. Unless this were like a malware, then I guess that's not how we'd want to do it. I'm just going to type something in here, hit enter. The system will always automatically break after it asks for user input. It gives us like a free break right there. So it stopped right here. It's popping something off of the status register. And then it's going to return. So there was an unlock door function right above us that we didn't come into. So if we continue again from here, and the program's over. Oh, one thing I was supposed to start doing is we're going to record this, the times of this. We're recording the times not to try to have any kind of bragging rights. It's going to be literally when I edit the video down to show you how long something took. I might cut out an hour of actual research or speed up. So I want you to actually see what actually happens there. So let's see here. Getting back to this. So the program's over, so we're going to reset it. And it tells us, the CPU needs to be reset. So we're going to reset it. And I think we can do, if I remember from the tutorial, we can do a break on main, right? Continue. There we go. So we set a breakpoint on the main function. Again, depending on, I don't want to assume anyone's background. So, when you write any kind of usually a C program or something, there's a main function, and we can just tell this program that set us a breakpoint right there. So when the code hits that execution, we're going to stop. So let's see. So here we have, it actually gives us some function names here. There's one called create password, enter the password to continue, and then it puts something onto the screen. It's a basic C function. Then it's going to get the password. Presumably, it's going to get the password from the user there probably. And then it's going to check the password. Then it's going to test the value of R15. And it's going to jump if not 0. So jump if 0 should be equal to jump, or jump if 0 should be equal to jump if equal. So this should be jump if not equal. We can look that up in a minute. One thing that we need to make sure we get real quick, because this is a new architecture, we need to know whether the format of this assembly is source and destination, or if it's destination and source. Some compilers or assemblers and architectures do it differently. So in this case, we can see here it's moving a very specific data type. The hashtag in front of it means the absolute value of this. So it means 0 in this case, literally 0. We're going to move that into R15. So this is definitely clearly a source and destination scenario, which is good. We have to know that in order to understand the code. So as you can see, I've been clicking all through here and turning on breakpoints on everything, which is not what we want. So we check the password. It jumps if not 0. And then if it doesn't jump, it says invalid password. Okay? So right there, we know this check password function is really where the meat and potatoes is. And then we come out here and we test. And so just for fun's sake, I mean, we can set like a breakpoint here, and we can continue. And it's going to ask us for a password. And once, it's going to automatically stop as we return from the function. And here's the test. So one thing we could do, it's actually kind of cool, is we can check the value of the status register, right? The status register is, I have a tab open here already. Status register is going to contain the values of previous operations run. So when things are compared, there's a carry bit. If things are added or subtracted, there's a carry bit. If they're compared, there's a 0 flag. So the status register is in the SR register, and it looks like this. The format of the 2 bytes is laid out just like this. And so we can see that this is the carry bit, this is the 0 flag, and the N is for, what is the N for? Carry. This is when we Google things. Negative flag. Oh, the number's negative. I think I read somewhere that this processor doesn't really take advantage of that. So in this case, the flag that's being tested is this. So it's in the 2's position of the binary string, right? So if we look back at our code here, if we see that the SR is currently equal to 0, and we remember that in help there's this option here, we can let a variable. So let's say let SR equals 2. Let's turn that bit on. We lost our connection to the lock. Reset, continue. And say let SR equals 2. So now we've seen that this variable right here changed. It changed, and it actually tells us when we hover over that now the 0 bit is set. Actually, we want to step one more time before we do that, because it's going to get changed by the test command. So I ran it while the test command is the next one to get activated. I need to run it now, because we see it was set to 3 by default, and we're doing a jump if not 0, so I want to disable that. So if you picture this binary string, right now the 2 and the 1 are set, and we know that the 2 is a 0 flag, so we want to unset it. I did it wrong the first time. So let SR equals 1. Now we can see this value is set. Hovering over it shows us only the carry bit is set. If we continue, the lock should be unlocked. Great. So we did get in that way. However, we can't solve it this way. If we try to solve it, we can't modify the code. So we need to actually figure out what it was doing. So we're going to go back to our breakpoint here, and we want to follow this this check password. We're going to test R15. Well, for testing R15, we're going to look up the test command. So I'm just searching for the test. So test takes a destination variable, and it's got to be comparing it to a register, right? So it's funny, I just did this like a week ago, but it's not fresh. So just need a succinct spot for this. It is. That's not what I want. Why do I not remember where this test comes from? It's basically comparing it to 0. Oh, it's comparing it to 0. I saw that on the first page. Oh my gosh. It basically acts as a compare to the straight value 0. I don't know why. I saw that on the very first thing I looked at. I completely just didn't process it. So that's kind of the point of this whole video series, right? That's what I want people to see, is that like nothing is clean and clear and easy. I mean, I'm sure you watching this were like, dude, it's right there. What's wrong with you, idiot? But yeah, it is what it is. So we're testing this against 0, and so we can see right here R15 is 0. And so we're going to jump if it's not 0. We instead want to find out, we need to see this checked password call. So it's at 44 BC, which is not far from here. Check password, 44 BC. Let's drop a checkpoint on here, breakpoint. Clear this one. Let's go ahead and reset our continue. Throw it in here. Continue without hitting fat fingers. All right, so now we're in the check password function. It's going to, we see at the end here, it's going to clear R15 and then return. So with our fake password, if we just step through this a bit, we see it's moving R15 into R13. R15 holds this address, 43C9. 43. I'm just counting out from the end here. So it should be 90, 91, 2, 3, 4, 5, 6, 7, 8, 9A, 49, C, B, C. So it should be these values right here. Actually, I think it's these values right here. I think I miscounted. Because obviously we see the string test right here. So it's all of this. It's these 2 bytes right here. So we're comparing that I just want to know for sure. I have a... Yes, okay, so it was both, it was the whole group there. So this whole, this is the 4 bytes. This tool right here is called CyberChef. It's just a website that allows you to do all kinds of really helpful conversions to and from different formats. So, okay, so it's those 4 bytes at the end. It starts right there, and I literally just counted over from here. And we can confirm it says test right here. So that's the value that we put in. What is in R15 and now about to be put into R13 is what we typed. So let's step over this again. Okay, it's going to add R14 to R13. And it had just cleared R14 for this. And then it's going to compare. Going to compare the data in R13 to a value that is in R14. What does it mean? What's it 024? 2400? Well, that looks kind of interestingly suspicious to me. It's comparing something directly to the data in R13, which we know the data in R13 is at that address 439C, which is our string. So we're comparing to that. Okay, I think this is our value actually. So let's try to continue. Okay, invalid password. So let's reset again. Continue. Type in test. Continue. It's doing a byte compare. So it's straight up comparing the bytes. So let's go ahead and step through it a few times. So see, we didn't match right there. Right on the first byte, we didn't match, so it just booted us right to clearing R15 and sending us out. And we saw what happens, if we just step through again just to remind ourselves, we saw what happens if R15 is cleared out here, we test it, and it's no good. Okay, so having done this before, and I played with it a little bit at that point, I did go ahead and notice that there's this option here to check if we want to try hex encoded input. And so after some trial and error of probably, I don't know, 15 minutes or so, I finally went ahead and actually tried to put the same values that we saw in that variable into this box directly as hex, and let's see what happens if we do that. Let's send in test. Oops, turned on hex mode. So we got to go try to find out what that value was again. So if I continue, we're going to say so we get down to, I did continue again instead of doing step. So I just rushed us to the end of the program. I'm not gonna lie, I think I'm like a little stressed knowing that I'm doing this where people are like judging me and probably yelling at their monitors, so it's kind of an interesting way to do this. So now we're in the check password step, and we wanted to see it's comparing to, is it actually in R14 at that point? let's see, I'm going to step. So at this point, R14 is 0. I want to look up, I don't know what this whole thing is where it puts like an address, and then does it also copy it into the register when it's doing it? I'm going to step over it and see what happens. No. I don't know why it's got R14 in parentheses. I'm going to have to Google that. Oh, it's going to set the register value as if they were subtracted from each other. So I think it's just going to, and I think it's just going to okay. So I think it's just going to set that variable, that R14, based on the status of that compare. So at this point, if we step again, well, we need to know R13 has what we typed, 439C, and we want to see what's in this 2400, which is these bytes. And just a old school C programming thing, strings are always terminated with a 00 with a null. So we know that we need to capture that last 00 right there. So we're just going to copy this out. We are going to continue the program, reset it, and we're going to try sending this in as hex. And continue. I accidentally set this extra breakpoint that's going to run every time. Door unlocked. All right, so that was it. If we want to solve this, we can just type solve and make sure we got the hexadecimal turned on and go ahead and send that along. And that's it. We're back to the map. At this point, it would have unlocked Sydney for us. So there's a little bit of one thing that I kind of bothered me about the challenge itself was just that you had to know to send the raw hex. I guess they were trying to simplify the code to not actually have string compares, because I think that probably would have been more difficult. But it would have been weird. It took me longer just to figure out the first time took me longer to figure out just why I would have to send that regular raw hex. And the only real clue that I had, maybe there's a better clue that you guys could have told me about, but the only real clue I had was that the input field gave me the option to send raw hex. So that led me to actually try that. So that was it. Pretty quick. 20 minutes, but there was some hemming and hawing for me. This is my very first attempt at putting myself on a video, so a little bit of stress there. So I will try to edit this down, but you'll see how long it took to get through. And I hope you enjoyed the style. And as I get better at this, hopefully you'll get more out of them. So thank you very much.